Hello everybody. So this session is about Palo Alto routing parts. So it is very important to understand the routing if you are doing in troubleshooting, if you are implementing any policy, maybe you are designing any networks. So it is very important to understand in any of the production in any of the company. Okay, routing is very important. It's play vital role because without routing we can't do anything, right? We can't go on the internet. We can't communicate between source and destinations. So we need to. I'm going to explain this is not kinds of lab, but of course, this is not the basic things. It is above the basics, and on the basis of this session, I am pretty much sure you can implement and we can learn routings in Palo Alto very easily. Before starting from Palo Alto, we need to understand like what is routing and how many types of routing. So in routing, there are some types like a static routing and default routing and dynamic routings. And in dynamic routing, we have like interior gateway protocols, we have exterior gateway protocols, and in interior gateway protocols, we have like distance vector routing protocols. That is REAP. It is not more used in the production in the company. Then we have link state routing. So OSPF is the part of link state routing. Then we have exterior gateway protocols. And in exterior gateway protocols, there is only one routing that one in one routings that is BGP, and it's called path vectors. In path vector, only BGP supports. So BGP is the only one protocols. With the help of that, we can go on the internet. So BGP is play a vital role in the company. Okay, especially if you want to go, your activity is mostly on the related to internet or WAN side. So BGP play a vital role. Okay, so there are some routes in the Palo Alto, like first one is connected. So connected routes, what is connected routes in Palo Alto firewalls? So connected routes are IP subnet belonging to the firewall interface itself. So whatever the interface, so we have configured, we have put the IP address, we have put the subnet, that will be the part of connected routes. Okay. Connected are the most commonly used route for redistribution. So when we are doing redistribution, like from BGP to OSPF or a static to some other stuff, some other routing protocols, or like OSPF to BGP, BGP to OSPF. So basically connected routes, connected interface route basically use on that times. One more thing important to understand, guys, we need to keep like any /32 interface. The interface we are going to configure and using /32, it will consider as a host, okay, and therefore cannot be redistributed, and we can't redistribute it. So if you are putting any interface and using the value /32, it will consider as a host, and therefore we can't redistribute it. Okay, so we can understand and we can keep in your mind also. Then second one is like a static routing, guys. So a static route basically it is very less used and mostly used in the small organizations. So a static routing basically, the routing which administrator manually puts in all routing table informations. So a static route that is created manually by network administrator. Okay, so routers routing tables entry are populated manually by network administrator. So static routes basically where we created manually. Let me tell me some examples. So, for example, this is our firewalls. Maybe this is our ISP. Maybe this is our DMZ server. Maybe DMZ switch, and there is a DMZ server is there. There is another here, like for example, there is another here PC, maybe on the internet. It is your part of this. This is the part of 10.10.10.10.10 subnet /24 subnet, and this is the part of like 20.20.20.0/24 subnet. So like 20 want to communicate with 10. So like on the this router, maybe we can add on a static route like go on the configuration terminal of the routers and run the command like IP route 10 dot 10 dot 10 dot 0 and put the subnet mask like 255 255 255 255 dot zero. So I want to communicate with these destinations, with this subnet. Please this send this traffic to the next hop, that is maybe this firewall egress and interface IP address may be considered 1.1 192.168.1.1. So we can give the next hop here 192.168.1.1. So so these types of things in these types of scenario we can use a static routes where a less requirement and a small organizations is there. Okay, where we generally configure manually. So this is about a static routing. Okay. Then we have the default routing, guys, and it is very, very important to understand default route. So default route is also known as the gateway of last resort in is a special type of a static route. Okay, so this method where all routes are configured to send all packets towards a single device. For example, there is multiple destinations. For example, we have, for example, till 10 routing in our routing tables. And for example, there is 11 traffic coming to the firewall. So and that entry known to the routing tables. So it is going to be use the default route, and it is going to be sent to the single next hop. Okay, so this is how we can define 0.0.0.0/0. So any traffic which is not matching, there is no any entry for that traffic, it is going to use the default route and pointing toward the single next hop, that is in this diagram 17.2. Okay, so a default route, also known as the gateway of last resort, is a special type of a static route. Okay, where we can send all packets towards single device. Okay, so default route is a network route used by device, when there is no other known routes exist. So I mentioned earlier, right? So if there is no any entry in the routing tables and traffic come into the firewall, it is going to be use the default routes, and it is going to send to the single next hop. Okay, so all the IP diagram with unknown destination address are sent to the default route. So if there is no any entry for the destination, there is no any entry for the destination, it is going to use the default routes. So this is how default routing work. Okay. In default route also, guys, we can use maybe multiple next hop, and we can define with the help of a metric, and list will be more prepared. So if you're using metric 10 and 20, so 10 will be going to be picked first, and then 20 is going to be picked in second times in second place. So priority will be less, metric will be more priority. Okay. Then we have dynamic routing, guys. So dynamic routing, I hope I mentioned earlier also, so everybody aware, like we have OSPF, BGP, we have REAP, EIGRP, all of the part of dynamic routing. I'm not going to cover each and one everything, because this session is just about the overview of the Palo Alto routings, and maybe next upcoming session we'll try to implement some things related to BGP and OSPF. Okay. Administrative distance, very well, like you know some like routing protocols, some like static routing, and like IBGP, EBGP. So IBGP AD value is 200, EBGP 20, REAP is 120, OSPF is 110, and OSPF internal is 30, and static route default is 10. So we should be aware while implementing it. So it is very good things if you remember these things. If not, we can use the PDF or maybe take the help from the Googles. And the route metric is also very, very important. So route metric basically comes in the picture where, for example, um, I just mentioned above, guys, this one. So for example, if you are pointing some destinations using default route, or maybe other static routes, and for different destinations, and you are using, for example, using the next hop with the same, so we can use like metric less, so less will be more prepared. So we can use as per our requirements. Okay, so these are the two things. It is very important to understand. Administrative distance, metric less will be more prepared. So if you are putting AD value and metric on any routings, the AD value and metric is less is going to be prepared first. So in priority case, it will be considered as first. Okay, that's it. Okay. Okay. So yes, now two things, two more things is very, very important to understand in IP routing tables in Palo Alto firewall. First one is RIB. RIB is routing information base. Okay. So what is RIB, guys? RIB is routing information base in Palo Alto. It is going to, and it is going to be contained, it is going to maintain all the routes learned are placed in the routing information base. So whatever learn from different protocols, it is going to be maintaining routing information base. Okay, and we can use this command, show routing route command, to will display the routing information table from the firewalls. Okay, it's very, very important to understand RIB, routing information base. In routing information bit is going to be, it's kinds of contestants, it kinds of customer, we can say. It is going to be maintain all the entry in database related to routings, whatever directly connected, whatever learned from different routing protocols. Okay, so that about the RIB, routing information base. Second one is FIB, forwarding information bit. It's going to be, it's kinds of, taking details from RIB and maintaining FIB where we are going to put the based route. Okay, so FIB is Palo Alto firewall term, which is stand for forwarding information base. And base route obtained through the protocols are used to populate the firewall FIB. So whatever the best route, it is going to be learned from the RIB. It is going to put on the FIB, that is forwarding information base. And we can run the command like show routing FIB to check the forwarding information base. Command will display the FIB table from the Palo Alto firewall. Firewall chooses the best route towards destination network to place in the FIB. So RIB, it is going to take the detail from RIB and put in the FIB, that is forwarding information base. It is going to be put the base routing informations. Okay. Yes. So this is about FIB and RIB. So I hope you guys understand. Let me some explain like with the help of some example also. So for example, this is our RIB and this is our FIB. Consider it. Okay. So let's consider here. There is one subnet like 10 dot 10 dot 0 dot 0 or maybe slash 24. So this is the part of RIB routing information base. So it is going to be to make entry on the FIB like 10 dot 10 dot 0 dot 0 slash 24 or maybe other. Just consider 24. It is going to be put on the FIB. What about if you have the same slash value in details in the FIB, RIB, for example, 172 dot 172.16.1.0 slash 24. And another one is again other is learned from maybe some OSPF. It is advertised from OSPF 172.16.1.0 slash 24. So those are the same slash value. To how it is going to be maintained in the FIB. So it is going to be maintained with the help of lowest AD value. So which FIB in both of them have the lowest AD value is going to put in the FIB. If AD value is matching, it is going to be put with the basis of lowest metric. Okay. If metric is also matching, it is going to be prepare the highest slash value. Okay. So let's consider the one is here put one out of two, one is put in the FIB on the basis of metric 172.16.1.0 slash 24. Okay. There is another third routes. For example, 172 172.16.1.0 slash 25. So it is going to directly put here because it's a different slash value 172.16.1.0 slash 25. Maybe there is some destinations. Okay, maybe some destinations where this subnet is want to communicate with the destinations. Okay, maybe there is another default route is there in FIB, for example, 0.0.0.0 slash 0, and it is also for the same destinations. Next hop is maybe same or maybe destination is the same. So out of two, which is going to be look first? Slash. So largest slash value is going to be look first. It instead of the if you compare from default route also. Okay, so default route is not going to check in against of slash 20 largest slash value. So largest slash value is going to be look first, then it is going to be default route. Okay, so I hope you guys clear about the FIB, RIB, and how it maintain the entry from RIB to FIB. So it is going to pick the details from RIB to FIB and keep as a all the best routes. Okay. So this is about the Palo Alto routing parts. And before that, I'm going to explain two things. It is very, very important. That is equal ECMP in Palo Alto, equal cost multipath. So guys, ECMP is basically we use in case of load balancing the traffic. For example, we have two ISP, and if you want to use two ISP at a times, and some traffic if you want to distribute through ISP1, some from ISP2, so at that time, so we use equal cost, multipath. So ECMP is a routing strategy that allow packet to be forwarded to a single destinations over multiple paths that have the same cost or metric. Okay, so this technique commonly used to improve network performance by load balancing traffic across multiple paths. So ECMP can be implemented with various routing protocols such as OSPF or BGP and helps optimize bandwidth utilization. However, care must be taken to avoid issue like packet reordering, which can disrupt certain protocols like TCP. So in short, I can tell in upcoming session, maybe I'm trying to implement advanced routing in the lab also, but just understand ECMP is equal cost multipath. The features related to routing in Palo Alto where we use for the load balancing related things. Okay. Another thing is guys, policy based forwarding. Okay, policy based forwarding. So basically policy based forwarding enables you to override the default routing tables. So if you are using policy based forwarding, it is going to be override the default routing table whatever we have in the firewalls, and it is going to be look on the basis of source IP, destination IP, application, whatever we generally put in the policy based forwarding rule. Okay, so it is also kinds of load balancing. We can define some traffic towards ISP1, some traffic towards ISP2. So in that types of scenario, we use policy-based forwarding. Okay. So policy-based forwarding enables you to override the default routing tables and specify how traffic should be forwarded based on the parameters like source IP, destination IP, or application type. For example, you can route a specific type of traffic through a secondary ISP and a specific type of traffic toward the primary ISP. A particular interface, regardless of the destination IP, this is particularly used in scenario where you want to prioritize certain application or ensure traffic symmetry. So if you want like some, and I know if you want to like prioritize, give some priority for the some applications. For example, if you want like local applications should go via ISP1 and there is some critical applications which should go via ISP2. So we can prioritize things with the help of policy based forwarding, and it is going to override the default routing tables. So this is the meaning of policy based forwarding and equal host multipass in Palo Alto firewalls. Okay. Before closing this session, if you come with the firewalls and if we come with the networks and virtual routes, so at the moment only we have the default route. If you click here like more runtime state, so this is the route tables. So basically it stands of RIB routing information base. It is going to put all the details here. Okay, related to next hop, metric and all. This is forwarding tables. It is only put the based routes here like this default route and next hop is 192.1.1. This is our ISP router in my lab environment. Okay. So this is about the routing overview in Palo Alto firewalls. So I hope you guys understand, and this video is informative and knowledgeable for you guys. I just remember one thing before closing this session. There is one other terminology, service route. Okay. So what is route, guys? So service route basically. Let me come here. Yeah. Service route is, for example, this is our firewalls, and we have multiple interfaces there. Maybe okay. So by default, for example, here is one internal side one server is there, maybe one DMZ server is there. Okay. So by default, a firewall is going to be learn the route from the management interface. Okay. By default, it is going to be learn the route from the management interface of the firewalls. Okay. But if you want to, we can select put a specific interface in the, for example, this is our DMZ server, maybe consider just AD server. And this AD server is not connected through management interface. It is connected through Internet 1/3 of the DMZ, maybe example. So we need to go on the service route and change it. Okay. DMZ server is connected to our 1/3 interface. That is, we can select data planes. It is not the management plane, not the management interface. So this type of traffic should be learned through Ethernet 1/3, not the management interface. So these things we can change the service route. Okay. So service route in Palo Alto is a features where we can define our specific interface for the traffic perspective. Otherwise, all the things will be learned from a management interface. So if your DMZ server, AD server is connected to a management interface, that is fine. If it connected towards through other interface, then we need to go on the service route and then we need to change the interface, guys. How we can do that? We go on the device, go on the setup, then if you go on the services, and here there is option like service route configurations. By default, uh, use management interface for all. By default, this is the option, use management interface for all. But if we click on the customize, and we can use the interface. For example, let's consider in our case like we have already used it for user ID case. We are using Ethernet 1/1 and UID agent. So we can customize related to interface depends upon your infra, depends upon the design. Okay, so that's it about the Palo Alto routings. So if you like my efforts, please share, like, subscribe as much as possible. Let's meet on the next session. Thank you very much, everybody, and thank you much for your times. I really appreciate like you involved with this session. Thank you very much, everybody.